Tutorial 13, Movie Sequencing Introduction. In this tutorial, we will work with a few new objects, the slider, umenu, and loadbang objects. The slider object allows us to select a range of numbers using a single UI element. The umenu object allows us to pick an item from a pop-up menu within a patcher. The loadbang object is a setup object. It allows us to trigger messages when a patcher is first loaded. All of these are important items for more complex patches, and we will use them in the context of making some interesting video-driven programs. Providing user selections is important once your patch gets complicated, or if you want to share your patch with others. The slider object is great for selecting loop points, and the umenu object is perfect for selecting among a list of files or display options. Finally, loadbang gives us the ability to set object parameters when a patch is loaded, allowing us to create patchers that require a minimum of setup to get started with. A few new objects, slider, loadbang, umenu. Take a look at the tutorial patcher. This patch contains a few simple patches at the left, and two larger patches to the right. Let's start by looking at the left-hand patches, where we are introduced to our three new objects. The rightmost patch is the example patch for the slider object. Click on the surface, and you will see that the wiper will vanish. However, if you click the mouse then drag up or down on the surface, you will see that you can actually select a range of values reflected in the two outputs of the object. If you shift-click, you can adjust the end closest to the mouse. The name slider refers to the fact that this is a range slider, capable of selecting a range of values with a single mouse movement. The actual range that the slider covers can be set with a simple message, as we'll see later in the tutorial. The next object is pretty simple, but very important. It is the loadbang object, and it sends out a bang whenever the patcher file is loaded. This is most often used for setting up values in a user interface. In this case, we are loading the number box with 55 each time we open the patch. We can also force the loadbang to fire by double-clicking on it. If we change the connected number box to another number, double-clicking on the loadbang will cause a bang message to hit the message box, and the number box will again update to its previous value. Loadbang will not produce a bang when it is created or copied, so it is easy to get new work out of sync with what will happen when a patcher is loaded. Be sure to give them a double-click before testing a patch. Better yet, save, close, and reopen the patch to confirm that loadbang is doing its job. If you need to duplicate the action of a loadbang automatically, it will respond to a bang in its inlet by sending a bang. Finally, the umenu is shown in the bottom of the three small patches. If you click on the umenu, it displays a set of options as a pop-up menu. Selecting one will produce two forms of output. The left outlet will send the index number of the selection, starting at 0, and the middle outlet will output a symbol containing the text of the menu option. The items available in a umenu object can be set in a number of ways. In the next section we'll look at how to populate it automatically. First, however, unlock the patcher and open the inspector for the umenu object on the right-hand toolbar. In the inspector you'll see a section labeled Items. Within this section we can view the list of items contained in the umenu. Click on the Edit button next to the list and a window should open that will allow us to type in anything we want. Items in the umenu need to be separated by commas. Add to the list, click OK, and close the inspector. You should see the umenu change to reflect the new items we've just added. Loading umenu with file info. The first large patch is labeled 1, and has two interesting sections. The top area is used to select movie files from a folder of movies that ship with the Max distribution, while the bottom area is used to loop the playback of these movies within an iMovie object. Let's start by looking at the top section. What we have here is a rather complete file selection system. A loadbang object is used to trigger a message box that sends the message prefix. Patches media to the umenu object. If we look at the reference material for the umenu object, we see that prefix is an attribute that sets a menu-wide prefix that is added to the beginning of any selected item. It has a second use as well. It tells the umenu where to load files when it is told to populate. The umenu object has its auto-populate attribute set in the inspector, so when the prefix message is received, the umenu is loaded with the names of every file in the folder pointed to by the prefix message. As a result, we have a Umenu loaded with file names from a folder called Media, inside of a folder called Patches. The Patches folder is actually found within the Max application bundle. Otherwise, this form would refer to folders relative to the folder where Max is installed on your system. Most of the time, your paths will be relative to users. When we select one, three things happen, thanks to the trigger object connected to the middle outlet of the Umenu. First, the message dispose is sent to the iMovie. This clears the iMovie object of any video file that is currently loaded into it. Next, the symbol containing the name of the file with the folder prefix Patches media prepended to it is sent out. The read message is placed in front and then sent to the iMovie. Third, the trigger object sends a bang through a delay object, which delays the message by 100 milliseconds. This gives the iMovie object time to read in the movie. After the delay has expired, the message box below is triggered. It contains a few initialization messages to iMovie, length, loop 1, and start. In this case, although we have a number box connected to the left outlet, we aren't doing anything with the Umenu object's index. Everything is triggered by the middle outlet. Note how the trigger object is extremely useful in this case, allowing us to set up a complex series of steps in the correct sequence. Dispose the previous movie, read the new movie, find out its length, tell it to loop, and start it. Select a movie from the Umenu, and notice that it will load and quickly begin playing, looping at the end of the clip. If you select a different clip, the previous one will be disposed and the new one will start looping. Using the slider to set loop points in addition to loading and starting the movie, that length, loop 1, start message had another consequence. It forced the movie length out the left outlet of the iMovie object, and set a new chain of events in motion. This length message is used to set up the size of an slider, and set the object with its complete range selected. We can easily change the contents of the slider by clicking and dragging within it, therefore changing the loop points that the iMovie will use. To best see this in action, select the movie. Countdown. Movie. From the Umenu at the top, this is the familiar movie that counts down from 10 to 1. Now, if we click and drag in the slider at the bottom of the patch, you can see that we change the start and end points of the loop. The output of the slider object is sent to a pack object and then used to create a loop set message, which changes the looping in and out points honored by iMovie. In addition, it rewinds the film to the start of the loop message. This section of the patch shows a very common use for the slider object. It is initialized with the length of a media file, then is used for playback start and end positions. Setting things up, load bang and screen size. Finally, we are going to see how load bang can be used to completely set up a patch for the user when it is first opened. This patch takes the current mouse location and uses it to decide where to place a movie within a 320 by 240 pixel display area. The mouse state is pulled, and a rect message puts the currently playing movie, in shrunken form, at the specified location within the iMovie object. To begin, one load bang message is used to load the bball.mov movie file when the patch is first loaded. This way, you does not have to find the file themselves. Secondly, another load bang is used at the top right of the patch. It sends a bang message to the screen size object. The screen size object outputs a list of 4 coordinates representing the coordinates of your primary display. The last 2 elements in this list are, for all intents and purposes, going to give us the width and height, in pixels, of our screen. The mouse state object, as we remember, puts out the position of the mouse within that range starting at 0, so if we subtract 1 from the screen size, we can properly scale the output of mouse state into the range 0 to 1. This is a common trick when working with mouse coordinates, as we seldom use their actual pixel values. More often than not, we simply want to use them to control an entirely different range of numbers. Once the scale object has its maximum input set by the screen size object, the current mouse position will always yield values between 0, 0 and 1.0. These are then multiplied by 240 and 180 to get the upper left-hand screen location for the video placement within the iMovie object. The 80-60 portion of the rect message sets the width and height of the rectangle within the iMovie as a result. For a 320 by 240 window, Our maximum input coordinates should be 240 and 180. Turn on the Metro object with the toggle to begin pulling the mouse, and click on the Start message. Move your mouse around the display. You should see a small version of the basketball movie track your current cursor's location, and it will always be scaled correctly no matter what display you run it on. Summary: in this tutorial, we've learned about 3 very important new objects: slider for range selection, menu for the creation and selection of a list of items, and load bang for initial state setup. In addition, we saw how the screen size object can be used to find out information about the size of your display. We demonstrated them by creating some complex video playback systems that controlled loop length and display positioning. These objects will be some of the most important tools you will use on future patches.